The second metaphor that we're going to talk about in this module is related to carbon dioxide in particular. So in the last one we talked about the heat trapping blanket. Here we're going to use the metaphor of rampant versus regular carbon dioxide. So in this explanatory metaphor, this is a metaphor for anthropogenic carbon dioxide. So anthropogenic means human caused. And remember, if we're talking about the source of these carbon dioxide emissions, it's all of these human activities like transportation, burning fossil fuels, that kind of thing. So this metaphor is useful for explaining some of that. This metaphor is also useful in conjunction with the heat trapping blanket metaphor because this metaphor explains some things that the heat trapping blanket metaphor can't. So the heat trapping blanket is focused on heat, and here if we're talking about instead carbon dioxide, the two are definitely related, but we'll also talk about in a couple slides how there are some things that this carbon dioxide can explain in terms of climate change that the heat trapping blanket actually cannot. So here for the rampant versus regular carbon dioxide, the story that we're telling in this scenario is that regular carbon dioxide is used and created by normal life processes. So there's always been carbon dioxide around and we actually need it for some things. But what's happening now is we have these rampant or out of control levels that are too high, and those levels of carbon dioxide come from burning fossil fuels for energy. And so we need to reduce that rampant level of CO2 because it's getting out of control. And so one thing to note here is that this word rampant is maybe something that the person you're talking to isn't super familiar with. This actually isn't a very high frequency vocabulary word. So it's important when you're using this metaphor to put it into context and explain what rampant means. It's used in this instance because regular and rampant, those are it's a catchy phrase that you can remember, but it's also important to remember that you might have to explain that term. And so when we're using this regular versus rampant CO2 metaphor, what we're doing in this case, just like before, is we're redirecting thinking away from non-productive patterns. And so one of the common misconceptions is that, CO2 is natural, so it has to be good. So that's a misconception that we're trying to dispel with this particular metaphor. Some people often confuse carbon dioxide with carbon monoxide. Those are two different things, so we're trying to dispel that misconception. Some people think that the main problem with the oceans is material pollution. That is an issue, but this metaphor will explain how carbon dioxide is actually a bigger threat. Similar to what we talked about with the heat trapping blanket metaphor, some people will think that nature will fix itself and that we don't have to do anything, but this metaphor helps to convey that we do indeed need to take some action. Some people think the solution to this is recycling. Again, recycling is great. That's not going to address this particular issue. A hole in the ozone layer is another misconception we talked about before. And again, this idea that climate change is natural, so there's nothing we need to do about it. Using this rampant versus regular CO2 metaphor will help to redirect thinking to more productive, solution-focused thought. And we talked about the heat trapping blanket metaphor before, and I said there are some things that the CO2 metaphor can explain that the heat trapping blanket cannot, but I think it's also really important to point out that these two work together very well. So if we look at what's shown here at the top, it says that rampant CO2 adds to this heat trapping blanket. So they're working together. So when you have high CO2, that's contributing to this heat trapping blanket here. It makes a thicker blanket, which traps more heat. And so to solve that problem, we need to reduce that rampant CO2 and act on climate. So these two metaphors work very nicely together, and you don't necessarily need to only use one and not the other. And so for this particular metaphor, when you're using it, what you want to do is first of all start by explaining that some carbon dioxide is a part of normal life processes. So if you think back to BIO2, if you took BIO2 here, or another introductory biology class at a comparable institution, you've learned that plants use photosynthesis to produce their own sugars. They do that by using carbon dioxide that is released from other organisms like us when we are doing cellular respiration. We're producing carbon dioxide that the plants, like the trees, are using for photosynthesis. So some carbon dioxide is indeed a part of normal life processes. When I was looking for images and I found this one on the left, it hit a little too close to home and it looked very familiar, and so I decided to make my own California version of it. If you know anything about me, you know I always talk about my dog Enzo. So here I've created my own version where we are on the beach walking, we're releasing carbon dioxide that these palm trees are then using for photosynthesis. This here is that SIO pier, which is where the fish egg data was collected that we were working with earlier. So bringing that full circle. So when you're using the metaphor, first you want to acknowledge that some CO2 is part of normal life processes. And part of the reason why that's beneficial is, just like we always talk about, I always say I want to activate your prior knowledge. This is actually a way to activate the prior knowledge of whoever you're talking to. They're likely familiar or have heard of the fact that plants use carbon dioxide, so it's a way to have some common ground when you're starting conversation with them. Next, what you want to do is introduce the fact that we are producing too much or rampant carbon dioxide by burning oil, coal, and natural gas for energy. So here in this image on the bottom right, we have on the y-axis million metric tons of carbon emissions. On the x-axis, we have the year, and then we have different sources of emissions. And we can see that coal, oil, and gas are showing the largest surface area here, which means they're contributing the most to carbon emissions in this industrial age. So you're first acknowledging that yes, some carbon dioxide is normal, but then here you're introducing that rampant part where it's out of control. We have too much, and that's because we're burning these fossil fuels for energy. Next, you want to explicitly state that, just like before when we talked about with the heat trapping blanket, you want to explicitly state that rampant CO2 is building up in the atmosphere and in the ocean, and it's causing problems. So again, this is a very nice tie-in to that heat trapping blanket metaphor that we talked about, where you can even talk about the same thing, where as that carbon dioxide is building up, it's creating that gassy blanket, our favorite term, around the Earth. So you can talk about how carbon dioxide is creating a thicker blanket. Another thing, as I said, this carbon metaphor explains some things that the heat trapping blanket metaphor can't. One problem for this rampant CO2, or one result of this rampant CO2 that's causing problems in the oceans in particular, is something called ocean acidification. And so when this CO2 is being released when we're burning fossil fuels, some of it is released in the atmosphere, in the earth, and causing that blanket. Some of it is being absorbed by the oceans. And what happens when the carbon dioxide is absorbed by the oceans is that carbon dioxide reacts with the water and reacts with carbonate ions and forms something called carbonic acid. And so the effect of having this carbon dioxide in the water is that it's removing these carbonate ions. So these carbonate ions are no longer available because they're bound to that carbon dioxide. That is important because many organisms in the ocean that create shells or that calcify, so that means they have some kind of hard exterior shell or skeleton. So snails are an example of a calcifying organism. Corals that we talked about have this hard exoskeleton. That's also a calcifying organism. The problem with ocean acidification is that they need these carbonate ions to help form their shells and to calcify. And so if those carbonate ions are no longer available because they're reacting with that carbon dioxide, what happens is they can't produce their shells anymore. So you end up with organisms that can't produce those shells that they need to survive. They have really brittle structures. So rampant CO2 is leading to problems like climate change in the, like ocean acidification in the ocean, and that's causing a whole different set of problems in addition to this heat trapping blanket. And then just like before, you always want to end with solutions. And so what you would close with when you're using this rampant versus regular CO2 metaphor is you would want to explain that reducing the use of fossil fuels is the solution. So if the problem is that we have too much carbon dioxide, the solution is to emit less of that carbon dioxide. And so we do that by reducing our use of fossil fuels. And again, we can accomplish that by shifting to sustainable energy solutions like wind power, which is what's shown here in this image. So when we used the heat trapping blanket metaphor, I had that fun little cartoon where we had the earth and its gassy blanket and it was all cozy. When I looked online, I couldn't find a good example of this for the rampant versus regular CO2 metaphor, so I'm going to ask you all to actually create your own. So this is part of your homework. One of your Canvas quizzes is to draw a pictorial representation of this rampant versus regular CO2. You can do it in either multiple cartoon panels like we saw with the Earth, or if you want to do one big cartoon that encompasses everything. It's up to you, but there will be instructions on Canvas, but that will be your task, is to come up with a pictorial representation to explain this rampant versus regular CO2 metaphor.